Okay, in this seventh and last video on circles, we're looking at one of the trickier bits with circles. Really the only sort of bit where they can give you something which is difficult with circles. So this would come under the A category. Let's have a look at it. If I call that A and that B, yes? If that circle's got center A, that circle's got center B. The distance between the two is D, yeah? If the two radii add to give you D, the distance between the centers, then the circles touch. What's more, A, P, and B will be collinear, lie on the same line, and P splits AB in the ratio R to R. Yeah? Big R to little r. Okay? So sometimes we might be asked to find point P, and we'll get that by knowing that these 3 points are collinear and it's split in the ratio of the radii. The other way, this is called touching externally. The other sort, internally, is like this, where you've got a point P there. Okay? And in this case, then the big radius is equal to the distance between the centers plus the small radius. Okay? So it's like that. It makes sense if you look at it. And again, you know, if we're asked to work that out, then we know, if you knew the two centers, then you know that would go R beyond it. Okay? So if you knew that was A and that was B, yeah, you know A, B, and P are collinear. Okay? And this time you'd know P is an extension, yeah? So it would be, so basically, center B splits AP in ratio, D to R. Okay? So it basically goes R beyond B. Again, if we were asked to work out a point P, we could use that to work it out. But if we're just asked to say whether they touch or not, it depends on if it's externally, the radii adding to give you the distance, and if it's internally, then the big radius must be the distance between the centers plus the small radius. Okay, we'll go through 3 different examples, having a look at this sort of thing. Okay, let's look at our first example. Given a diagram like, if you're not given a diagram, I would sketch a rough diagram, okay? Doesn't have to be perfect, but it gives you an idea of what's going on. But here we're given a diagram, and we're told that the line joining the centers is vertical, so one center of one circle is directly above another. We're told that the equation of A, this bottom circle here, is that, and we're asked to find the equation of B. Well, if we have a little look at it, I need, first of all, the radius and the center of A, okay? Because look, I know twice the diameter there and the diameter there adds to 14, yes? So twice the radius of this one and twice the radius of that one is 14. So if I can get the radius of this one, I can work out the radius of that one. Secondly, if I know the center of this one, if that one's vertically above, that center is simply going to be a big radius and a small radius above that center there. Okay, which means only the y coordinate would change. Right, that's sort of looking at it and thinking about what we're going to do. So we start off with looking at this equation and saying, I need to get the center and radius from that one. So if we look at it, you've got x squared plus y squared minus 10x minus 12y plus 45 equals 0. Okay? If you remember, we are comparing this with, remember this one's given to you. So if you compare them, you can see that G is minus 5, F is minus 6, and C is 45. Okay, so we know our centre is minus G minus F, so 5, 6, because it's minus G minus F. Okay, and remember our radius is root of F squared, well, G squared plus F squared minus C, or F squared plus G squared minus C. As long as you square these two, add them together and take away C, you're fine. So minus 5 squared plus minus 6 squared, make that a bit bigger, take away 45. If I work that out, it gives me a radius of 4. Okay? Now, we now know the centre of this one, which is 5, 6. And we know it's got a radius of 4. Yeah? So we know, if we call this one big circle, big R, you know that 2R plus 2, twice the radius of the little one, is equal to 14. But we now know that our big radius is 4. So what we've got is we've got 8 plus 2R equals 14, which means our little radius has to be 3. Now, if we're looking at this one, we now know that this centre is going to be 4 up there and 3 up there. Yes? So the new centre, the centre of small, or centre of B, circle B, is going to be 7 more vertically, which means 7 on top of the y coordinate. So that one's still going to be 5, but it's going to be 13, because remember, it's 4 plus 3 above that one. Okay, we can write down the equation of circle B now, because it's simply going to be x minus 5 squared plus y minus 13 squared equals 3 squared. Now, we should probably give it in the same sort of form that they gave us A. So I'm going to multiply out these brackets and tidy up a bit. If we multiply that out, remember x squared minus 10x plus 25. This one plus y squared minus 26y plus 169 equals 9. Take everything to one side. You've got x squared plus y squared, because remember we do the x squared plus the y squared, then the x term, then the y term, lastly the number. Well look, 9 away from 169 is 160, 160 plus 25 is 185. So plus 185 equals 0. And that is the equation of circle B. Okay, let's look at our second example. Haven't given us a diagram here, but they say show that the circles A and B touch externally and find the point P where they touch. What I've written in red here is given to you on your formula sheet. Okay, it's one of the two versions that are given to you. Remember, this is the equation of a circle, what the centre is, what the radius is. So for A, we've got that G is minus 3, F is minus 4, and C is 0, because there's nothing added on here. So you can think of it as plus 0. Okay? Therefore, we have the centre of A. Now, I need to call the centre of A something. I'm going to call it D. I'd avoid using C, because quite often there's too many C's involved. So I'm going to use D. So the centre of this one, remember you just change the signs once you've got F and G. So it's 3, 4. The radius is just the square root of g squared plus f squared, take away c, which is 0. Put them in brackets, though if you're squaring them, remember, they'll always be positive. So 9 plus 16 is 25. Root of 25, you know, is 5. Okay, so we've got centre, 3, 4, radius, 5. In fact, I'll call it our A, so we know it's the radius of A, because we're now going to do the same thing for B. If we look at this one, this time G is half of that, which is minus 12. F is half of that, which is minus 16. And C equals 300. So I'll call the centre of this one E, okay? Change the signs, 12, 16. The radius is minus 12 squared plus minus 16 squared, take away 300. So 12 squared, 144. Remember, you lose the negative because you're squaring it. 144, 16 squared, 256. Add them together, you get 400. Take away 300 is 100. Root of 100 is 10. So the radius of B is 10. I'm now going to do a little sketch. Now we're proving that they touch, so we know these two circles touch. So, smaller circle there, bigger circle there. We'll call that P, the point they touch. Remember, we called that D, that E. Okay, we know D is the point, what was it, 3, 4. E is the point, 12, 16. Okay, we know this is a straight line, and we know that distance is 5, that distance is 10. So that's a little sketch. Doesn't matter that it's not perfect with the circles, but it's a little sketch of roughly what it looks like. We know that one's bigger than that one. It's twice the size, in fact. Excuse me. Twice the size, in fact. Okay, so now we need to prove that they touch externally. Remember how we do that? We want the distance between D and E. So the distance DE, using our distance formula. So we've got 12 minus 3 squared plus 16 minus 4. And if we work that out, that gives us 15. Okay? Now, at this point, we would say, look, the distance, so distance DE is equal to the radius of A plus the radius of B, because we know 15 equals 5 plus 10. So, yeah, therefore, circles touch as required. Remember, if we can show the distance between the centres, it's the same as the two radii added, they touch. That was our condition for touching. So that's the first bit done. But then they asked me to find out the point where this happens. Okay, but remember what our ratio is. RA to RB is 5 to 10, let's make it easier, which is the same as 1 to 2, isn't it? That's the ratio of them. So if you remember from our section formula, okay, remember it's sort of the other way round. What we're going to want for P as a vector is going to be, okay, 2/3 of D, which is 3, 4, plus 1/3 of E, which is 12, 16. Okay? If we work that out, we get 6, 8. Okay, so P is, And we've got to write it as a coordinate to finish off with 6a. So that would be a tricky circles question. Okay, we'll do one more example. Okay, this is our final video, final question on the video about circles. Now in this one, they've given us the equation and they've helped us out by giving us it in the easier format of circles A and B. Okay? They've asked us to find the equation of circle C given that their centres are collinear. So we're told this is a straight line. Now, if we ever think about it, I can find the radius of C because I know the distance between the two centres, A and B, okay? Let's call that D, E, and F just to help us out. Okay, so we know the distance D to E must be the radius of A plus the radius of B plus twice the radius of C. So if I work out the distance between D and F and take away the radius of A, and the radius of B, okay, then what is left is twice the radius of C. So that'll give me the radius of C. Okay, and then I will know that E, that point there, will split D to F in the ratio of that radius plus that to that radius plus that. And so I can find the centre of C, which is E. Okay, so this is quite a long, definitely an A-class question, but that's what we're aiming to do with this question. So first of all, let's look at it. Circle A, we've got centre minus 12 minus 15. And we've got radius of A is the square root of that, which is 5. Now for B, we've got centre 24, 12. And we've got the radius of B is equal to 10, square root of that. Not very good scale drawing, but never mind. Sometimes they're not to scale, so you cannot rely on, it's just to give you an overall impression of it. Okay, we also need the distance, so I'm going to work out the distance D to F, which remember is from there to there. So what you've got is root of 24 plus 12 squared plus 12 plus 15 squared. Now, that is 36, that is 27. If you looked at it as multiples of 9, it's really a 4, 3, 5 triangle, isn't it? Except it's 9 times that. So it's going to be 9 times 5, 45. If you didn't spot that, okay, that it's a multiple of a 3, 4, 5 triangle, then you could just use your calculator, okay? And if you do that, whichever way you do it, you'll get 45 for that one. Okay, so it's 9. It's effectively 9 times a 3, 4, 5 triangle. Okay, so we know what the distance DF is. Now, I know RA plus RB plus twice that one, because look, RA twice RC plus RB must come to that distance there, which is 45. Well, we know the rest of it, don't we? So that gives us that 5 plus 10 plus 2 RC is equal to 45. So 15 off that is 30, divided by 2. You've got that the radius of C is going to be 15. Okay, so we've got the radius of C is 15. Now, the ratio that centre, so the ratio that E divides DF is, well look, that's 5, that's 15, so that's 20, that's 15, that's 10, so that's to 25. Or to make it a little bit easier, divide by 5, you've got 4 to 5. That's our ratio, okay? So, if we're thinking of these, remember we did the section formula in vectors. We're going to use that again here to work out where the center is. So, remember our section formula, okay? So I'm going to want, call it the vector from the origin to D. I'm going to want 5/9 of D, and D was, what was the center again? Radius 8, minus 12, minus 15. Plus, I'm going to want 4/9, because remember, it's got more of the one it's closer to. Okay, so it was closer to this one than it is that one. That's why it's 5/9, 4/9. Okay, and the second one's 24, 12. And if we work these out, okay, so we've got this and we're working it out. So if we do 5/9 of this, I'm going to have minus 20 over 3. And the bottom bit would be minus 25 over 3. Plus 4/9 of this will give me 32 over 3. Plus 16 over 3. Which, if I work it out, gives me 4 minus 3. Okay, so that means our center, which we've called E, is 4 minus 3. And we already know that our radius is 15. So we can write down our equation of the circle, which will be x minus 4 squared plus y. Now it's minus a minus, so it's a plus 3 squared equals, now 15 squared is 225. Okay, they gave us it in that form, so they're happy with it being left in that form. So you don't have to multiply out and organise with this. That would be your final answer. This is what I'd regard as a tricky higher circles question. It is definitely one of their more difficult ones, the sort of A category questions. So you'd find this towards the end of a paper. Most circles questions are a lot easier than this. So, however, that finishes circles. So you should now be able to do any higher question on circles. But as I said, don't worry too much about this. This is definitely from the difficult end of that topic.